In this lesson, you'll learn how to read bar charts accurately, compare values, calculate differences and averages, interpret stacked bars, and avoid dangerous unit traps. These skills appear frequently on the SAT, and mastering them will boost your data analysis score instantly. Before we begin solving problems, let's make sure we understand what a bar chart actually shows. A bar chart represents the size of a value using the height of a bar. Each bar stands for a category, such as products, months, or groups, and the taller the bar, the larger the value. Bar charts are extremely useful when you want to compare categories quickly. For example, if you want to see which product sold more units, or which group had a higher score, a bar chart makes the comparison visual and immediate. However, the SAT often adds small visual details that can mislead your eye, such as similar bar heights, different colors, or compressed axes. That's why reading the actual numbers is far more important than relying on visuals. Understanding how bar charts work is a core skill in SAT data analysis, and mastering this foundation will make every question in today's lesson easier. So let's take a look at the key ideas you must know. Let's review how to compare bars in a bar chart. A bar chart represents the size of each value through the height of the bars. When you compare two categories, always look directly at the numbers shown above the bars. Visual impressions can be misleading, similar colors, spacing, or bar heights can trick your eyes, so base your comparison on the exact values instead of the appearance. On the SAT, you'll often be asked which category is larger, smaller, or whether two values are equal. By focusing on the actual numbers, not how the bars look, you can make accurate comparisons every time. Now let's learn how to calculate differences correctly. When the SAT asks for the difference between two bars, your job is simple. Subtract the smaller value from the larger value. But there's a critical step that many students skip, reading both exact values first. Never try to estimate the difference by looking at the visual gap between bars. The scale, colors, or spacing can trick your eyes. Always write down both numbers, then perform the subtraction. In some cases, the SAT will ask for a percentage difference. The formula is: take the difference, divide it by the original value, then multiply by 100. For example, if bar A is 95 and bar B is 110, the difference is 15. To find the percentage increase, 15 divided by 95 times 100 equals about 15.8%. The most common mistakes are subtracting in the wrong order, getting negative values, or forgetting to check whether the y-axis uses thousands or millions, which can change your answer dramatically. By following this systematic approach, you'll calculate differences accurately every time. Here's how to read totals and averages in a bar chart. When the SAT asks for a total, your job is simple. Add the exact values shown above each bar. Never add by eye, always use the numbers. For example, if the bars show 80, 120, and 100, the total would be 300. Always pay attention to the units. If a chart uses thousands or millions, the total must reflect that scale. Next is the average, or mean. To find it, divide the total by the number of bars. Using the same example, the average is 300 divided by 3, which equals 100. A common mistake is forgetting that every bar must use the same unit before averaging. If one bar is labeled in thousands and another in millions, convert them before doing any calculations. Another common trap is miscounting the number of categories. If you divide by the wrong number, the average will be incorrect even if the total is right. By following these steps, read the exact numbers, check the units, and calculate carefully, you'll handle totals and averages with confidence on the SAT. Here's how to read a stacked bar chart accurately. A stacked bar chart shows both the total value of a category and how that total is divided into smaller parts. In this example, Category A consists of 60 units from Category 1 and 40 units from Category 2, giving a total of 100. Category B includes 50 units from Category 1 and 70 units from Category 2, for a total of 120. When the SAT asks which category is larger overall, your first step is to add the segment values. Never estimate totals by eye. The spacing and colors can make one bar appear similar in height even when the numbers differ. If the question focuses on a specific part, compare the segment values directly. For example, Category 1 is larger in A, while Category 2 is larger in B. A common trap is reading only the top number and assuming it represents a single segment, when it actually shows the total. Another mistake is relying on visual height instead of reading the exact values. To avoid errors, always read the numbers inside each segment and verify the total at the top of the bar. This simple routine ensures you interpret stacked bar charts correctly every time. Here's a classic example of how bar charts can be misleading. On the left, we have a correct chart. The y-axis starts at 0, so the difference between 120 and 135 looks appropriately small. The bars match the real size of the values, and nothing exaggerates the comparison. Now look at the chart on the right. The numbers are exactly the same, but the y-axis no longer starts at 0. Instead, it begins at 110. As a result, the bars appear dramatically different in height. Even though the real difference is only 15 units, it visually looks 2 or 3 times larger. This is one of the most common tricks used to distort data. By zooming in on a narrow portion of the y-axis, a chart can make small differences look huge and emotionally persuasive. The SAT will never ask you to judge by appearance, so always read the actual numbers above the bars, and always check where the y-axis begins. The visuals may mislead you, but the numbers won't. Here's why units can completely change your answer. Bar charts often compress large numbers by using unit labels like thousands or millions. When you see a bar labeled 150, that number might not mean 150, it might actually mean 150,000. If you overlook that small label on the y-axis, your answer will be off by a factor of 1,000 or more. Another common trap is when two graphs use different units. One graph might use regular units, while another uses thousands. If you compare the bars directly without adjusting for unit differences, you'll draw the wrong conclusion. And when the SAT uses decimals, such as 2.5 million, remember that it represents 2,500,000, not 2,500. The key steps are simple. First, find the unit label. Second, read the exact number on the bar. Third, convert using the unit multiplier. Only after converting should you compute totals, differences, or averages. Always check the units before you calculate. A single word like thousands can completely change the meaning of a number. Now, before we move on, here's what's coming next. In the second half of this lesson, we'll switch from explanation to realistic SAT-style practice. You'll work with bar charts that look just like the ones on the actual test, and you'll apply everything you've learned so far: comparison, differences, totals, averages, and spotting misleading visuals. For each practice problem, the flow is simple. First, you'll get a short, clear explanation, about 15 seconds, just enough to understand what the question wants. Then, you'll have silent time to think, read the chart carefully, and solve the problem on your own. Use that moment to slow down, check axes, check units, and avoid the misleading traps we discussed earlier. After that, we'll walk through a clean, step-by-step solution so you can confirm your reasoning and see the best path to the answer. So, if you're ready, let's move on to the practice section and try these skills with real test-style questions. Here is your beginner practice question. The bar chart shows the monthly sales for 3 types of books: fiction, non-fiction, and comics. Your task is to identify which category has the highest sales. Look carefully at the numbers above each bar to compare the values. You will now have 60 seconds of quiet time to solve this question. Take your time and choose the best answer. Let's go through the answer together. The bar chart compares the monthly sales of 3 book categories: fiction, non-fiction, and comics. To identify which category has the highest sales, the key is to read the exact numbers above each bar. Fiction shows a value of 80 units. Non-fiction is slightly lower, at 70 units. Comics, however, is clearly the highest at 100 units. Even though the bars look different in height, what matters most on the SAT is the actual number label, not the visual impression. Small changes in color, width, or spacing can trick your eyes, so always trust the numbers first. Since comics has the largest value, the correct answer is option C, comics. Remember this approach, reading exact numbers before comparing, because it will help you avoid many common mistakes in bar chart problems. Now let's move to the next beginner question. This time, we want to compare comics and fiction by finding the percent difference. To solve this question, read the exact values from the chart and compare comics to fiction. Then calculate how much higher comics is using the percent difference formula. Let's walk through how to solve this percent difference question. We want to find how much higher comics sales are compared to fiction. That means fiction is our baseline, or original value. First, read the numbers from the chart. Comics has 100 units, and fiction has 80. The next step is to find the difference. Subtract 80 from 100, and you get 20. Now convert that difference into a percentage relative to fiction. Divide the difference, 20, by the original value, which is 80. That gives 0.25. To turn this into a percent, multiply by 100. The result is 25%. The most common SAT mistake is dividing in the wrong direction or comparing to the wrong category. But as long as you use the formula, difference divided by original times 100, you will always get the correct result. So the correct answer is 25%. Here is your intermediate practice question. You're looking at a stacked bar chart showing sales for Category A and Category B across 4 quarters. Focus on the green segments and identify which quarter has the highest value for Category B. Here is the explanation for the intermediate problem. The correct answer is choice D, Q4. Let's break down why. Start by reading only the green segments, which represent Category B in Quarter 1. Category B is at 50 units. In Quarter 2, it increases to 75 units, which is a rise of 25. In Quarter 3, the value drops slightly to 60 units. And in Quarter 4, Category B jumps all the way up to 90 units, which is the highest value across all 4 quarters. Since our goal is simply to identify the quarter with the greatest Category B sales, the answer is the one with the largest green segment, and that is Q4. Here's an SAT tip. When you're working with stacked bar charts, always treat each segment as its own number. Don't let the total bar height mislead you. Identify the segment values first, and then make your comparison. That's the full explanation. This is the advanced practice question. Now look at the stacked bar chart showing quarterly sales for Category A and Category B. Your task is to compare their percent growth between consecutive quarters, and decide where the difference between the two growth rates is the greatest. Here are the options. Let's walk through the answer to this advanced question. We are comparing the percent growth of Category A and Category B across each pair of consecutive quarters, and we want to find where the difference between their growth rates is the largest. First, from Q1 to Q2. Category A decreases from 80 to 70, which is a minus 12.5% change. Category B increases from 50 to 75, which is a plus 50% change. The difference between these growth rates is 62.5%, which is extremely large. Next, from Q2 to Q3. Category A rises from 70 to 95, an increase of about plus 35.7%. Category B drops from 75 to 60, a minus 20% change. The difference here is roughly 55.7%. Finally, from Q3 to Q4. Category A goes from 95 to 85, which is about minus 10.5%. Category B increases from 60 to 90, a plus 50% change. The difference is around 60.5%. Comparing all three, the largest difference occurs from Q1 to Q2, where Category B jumps sharply while Category A decreases. Therefore, the correct answer is A, Q1 right pointing arrow Q2. Great work finishing this lesson. Let's quickly recap what you've learned today. You started by reviewing simple bar charts and practiced identifying which categories had the highest values without relying on visual impressions alone. You then moved into stacked bar charts, learning to treat each segment as its own data point and compare values accurately. Finally, you tackled an advanced question involving percent growth, and you calculated how changes in starting values affect the percentage increase. The key message is this: always trust the numbers. Read the axes, note the scale, check each segment carefully, and compute percent change when needed. Bar charts can be visually misleading, but with careful reading, you can uncover the real story in the data. Your skills are becoming sharper, and this foundation will support all future data interpretation tasks you face. Excellent work today.